Hello dear students, in our new computer and IT program. This year we will learn about a new programming language which is Visual Basic. Visual Basic is a programming language used to create Windows applications and web applications. Now we will learn some concepts and basics which is important for programming. Okay, let's begin our new lesson for today. Chapter 1. Chapter 1 is talking about problem solving. The first concept we will learn is problem. What is meant by problem? A problem is a situation that requires a solution, or it's an objective or output that we want to attain. It's a goal that we want to reach. Let's see some examples for problems. Preparing a meal is an example for a problem, because if I want to prepare a meal such as a cake, I have to follow some steps to reach my goal, or I have to put some ingredients together, mix them and put them in the oven to have the output or my goal, which is the cake. So preparing a meal is considered a problem because I follow some steps and at the end I got an output. Solve a mathematical problem. Build a building. Design a computer program. So these are all examples for problems. This will lead us to the second concept, which is problem solving. So if I have a problem or I have an output that I want to reach, I must follow some steps to reach this output. So what is problem solving? Problem solving are the steps, the activities, and the processes to be done to reach the output or the objective. The problem solving stages. The problem solving stages for any problem or for designing a computer program are: first, problem definition. Second, algorithm. Third, program design. Fourth, program testing. And finally, program documentation. We will take these steps in details. First, problem definition. What should I define about my problem? I should define three things. First is the output. What is the goal of the problems? What are the available inputs? And what are the solution steps or the operation to be done on the inputs to reach the output? Second stage is the algorithm. And the algorithm is a group of logically ordered steps followed to solve the problem. The algorithm is represented by something called, or a diagram called, a flowchart. Program design. When I perform the algorithm or I write the steps of solving the problem, I write them on a paper. I want to translate this paper or what I wrote on the paper to the computer. How can I translate this? I translate this flowchart to the computer by programming language, because we know that computer doesn't understand English. Computer only understands machine language. Okay, so I have to use a programming language. This programming language will translate what I wrote to the machine language. So in the program design step, I translate the flowchart to the computer by using a programming language. Program testing. Program testing is very important to see if my program is working correctly or not. Program testing is very important step to check the errors and correct them. And finally, the program documentation. I have to write and type, record all the steps taken for solving the problem. All the inputs that I used, all the outputs, all the algorithm, all the flowcharts, the programming language, the date of creation, and the last date of modification for the program, and who are the people who worked on this program. This is very important for two things: for the feedback and if more than one person participated in the same program. We said we represent the algorithm by something called the flowchart. Let's see what is the flowchart. Flowchart is a diagram that uses standard geometric shapes to represent the sequence of steps required for solving the problem or to represent the algorithm. So it is a diagram that uses standard, not any geometric shapes, standard geometric shapes to represent the sequence of the steps followed to solve the problem. A flowchart gives us some advantages. What are these advantages? First, it tells the programmer what he should do, what are the steps to be followed. It makes it easy to explain the program to others. And it is very important documentation tool. It is important for program documentation, okay, because it's done on the paper, so it is very important for documentation of the program. Let's see the most commonly used symbols to draw a flowchart. The terminal. The terminal is found at the start and at the end of the flowchart. The input-output. This is not called a parallelogram. It's called input-output because we are studying programming, not geometry. The process. The decision, and finally the flow lines, which connect the flowchart together and tell us the sequence of steps and how the steps flow. Here are some guidelines for drawing a flowchart. First, a flowchart should start and end with a terminal. If I have input data, I must use 4 words: enter, read, input, get. If I have output data, I use 2 words: print, output. Any arithmetic operation must be written inside the process. If I have addition, subtraction, multiplication, division, average, product, it must be put in the process. The flow lines are usually from left to right and from top to bottom. Are usually, not always, because in some flowcharts we will find that the flow lines will come from bottom to top. A variable refers to a memory storage that holds a value and has a name. When I draw flowchart or the sequence of solving a problem, I use variables. And these variables refers to data that has a name. By this, I come to the end of our lesson for today. See you next lesson.